these Chapter 4 videos, we'll be covering probability topics. The best way to use these videos is to watch with your notebook and take notes while I'm teaching. You'll need to pause the videos often to get the notes down, and then every time the video arrives at a you try problem, pause and attempt the problems on your own. The solutions will be shown when you press play along with the work. We'll start with the fundamental probability concepts. So a probability is a numerical value that measures the likelihood of an uncertain event that could occur. So you can think about maybe the weather. We say there's an 80% chance of rain, or we talk about probabilities quite often. What's important to note here is that probabilities are values between 0 and 1. Now, when we turn those to percents, they change to 0% to 100%. Impossible events are 0 and definite events are 1. So experiments lead to outcomes, and a sample space contains all the possible outcomes. So if we were rolling a dice, the sample space would be we could roll a 1, a 2, a 3, a 4, or a 5, or a 6. And if we were to flip a coin, the sample space would be we could get a heads or a tails. An event is a subset of the sample space. Maybe we want to know rolling a 1, or rolling all evens, or flipping a head. A simple event is one outcome. So events can be exhaustive or mutually exclusive. When you think about exhaustive, you want to think about that if the event is exhaustive, it's got all outcomes included. And if it's mutually exclusive, they have no common outcome. So this is when we're looking at kind of more than one event. So if we kind of think about these metals here, the sample space is gold, silver, bronze, or no metal. If we're talking about at least a silver metal and at most a silver metal, we're going to be including all the outcomes. And if we're talking about at least a silver metal and at most a bronze, those don't have any common outcomes, so those would be mutually exclusive. So in this example here, rolling a number less than 4 and rolling a number greater than 3. Are the events A and B exhaustive? They include everything? Include all the outcomes? Or do they have no common outcomes? So when we look at this, rolling a number less than 4, so that would be 1, 2, and 3, and a number greater than 3 would be 4, 5, 6. They have no common outcomes, so they are mutually exclusive. Go ahead and give this one a try. Press play when you're ready to see the solution. And there's the solution. So now we're going to talk about union. It's expressed with this U in between, and these are our or statements. So when we talk about union, we're talking about A or B. So we're talking about the event A, or we're talking about the event B. Now, there is overlap here, and we're going to deal with this later, but if we're dealing with mutually exclusive events, there is no overlap. We've got A and we've got B. But when we're talking about and, when we talk about the both of these events, we use this upside down U, and that is that overlap here, and this is that intersection, okay? So intersection is when we're talking about and or the word both. So let's do this example together. Consider the following scenarios to determine if the mentioned combinations represent a union. So that would be a union is our or. An intersection would be our and or both. So there are two courses that seem interesting to you. Let's call them A and B. You'd be happy if you can take at least one of them. So if you have at least one, that would be course A, or B would make you happy. So that is going to be a union. But if the two courses that seem interesting to you, you would be happy if you can take both. That means you want A and B to be happy. Well, that would be an intersection. Now, when we talk about the complement, we use this notation here. And basically, it's everything that's not an A. So if this is A, then the complement of A is everything that is not in A. Not A. And we've said this before, defining properties of a probability. The probability, we denote it with a capital P, and then we put the event inside the parentheses. It's got to be between 0 and 1. And the sum of probabilities of mutually exclusive and exhaustive events equals 1. So let's look at this example here. So a sample space yields 4 simple events A, B, C, D, and they give us the probabilities of A, B, C, but they say find D. Well, here's the thing. We know that all of the probabilities have to add up to 1. So the probability of A, so we know that this has to be equal to 1 minus all these other ones added up. So 0.35 plus 0.10 plus 0.25. So first add those all up. We get 0.7, so we get 1 minus 0.7, which means what's left over for D is 0.3. So the probability of event D is 0.30. So now they want the complement of C. Well, that's everything that's not C. Well, again, if we know that everything is 1, we want everything that's not C. So we want to take away the probability of C. So everything that's not C is 0.75. So now when we talk about the union here, when we talk about the union between A and B, we're talking about A or B. So it could be A or B. So that would be 0.35 plus 0.10, so that would be 0.45. Let's look at this example here. What is the probability that a randomly selected person wins either a gold or a silver? So if we were to use, let's see here, let's call this G, S, B, and let's say no metal, okay? So the probability of gold or, so if we use or, that is going to be our union, probability of gold or silver. That's going to be 0.10 plus 0.15, that's going to be 0.25. So the probability of, what is the probability that a randomly selected person wins neither gold nor silver? So we're saying not gold or silver. So the probability of not gold or not silver. Well, let's think about what those are. What is not gold, so, and not silver? So that would be really what we're talking about is the probability of bronze or no metal. And so that's going to be 0.2 plus 0.55, and that's going to give us 0.75. Are the events gold and silver exhaustive? So remember, exhaustive means, does it include all outcomes? No, it doesn't. It doesn't, those don't include all the outcomes, but are they mutually exclusive? They have no common, you can't get them at the same time? Yes, because you can't have both a gold and a silver. We'll do one more example together. So here we have a frequency distribution, and basically you can think of that as like a tally system. It summarizes the ages of the richest 400 Americans. What is the probability that a randomly selected person is between 40 and 50? So 40 up to 50. So they give us the frequency. This is the number of people. It's not the probability. So to find the probability, we would take the amount over the total. So the probability there would be 24 over 400, and we would just type that into our calculator, get 0.06. So what is the probability that a person is 90 or older? So that's this section here. So we're looking at 11 people out of 400. And remember, the 400 came from, they gave us the total. We could also total it up here. So that is going to be 0.0275. What is the probability that a randomly selected person is between 60 and 80? So 60 to 70, 70 to 80. So we're talking about both of those. So we could separate the fractions, or some people like, if they have the same denominator, you can write them as one numerator. Same idea here. And you type that in your calculator, you get 0.575. Is it true that 90% of the richest Americans are between 40 and 80 years old? So let's look at this. 40 to 80 is this section right here. 40, 50, 50, 60, 67, 70, 80. So we need to add up all of these and see if that probability is really 90%. So when we add those up, 24 plus 67 plus 113 plus 117, we get 321 over 400. What is that probability? It's 0.8025. That's about 80%, so no, it is not true. Give these a try here and press play when you're ready to see the solution. And there you go. And we're going to pause here and make sure to check back in for the next section rules of probability.